Hello webs, hi, this is Fahad from Future Phones, and today I have a MacBook Pro. The model number is A1278. The problem with this MacBook Pro is it's not powering on. This is the one. It's an old MacBook Pro, and the device is not showing any lights at the DC jack. So I just thought I'll take this opportunity to explain why this light is not showing up here. Let me just take you to the other cam here, and you can see there is no light at this DC jack. My power supply is set to 16.44 and the ampere is set to 3.57, which you can see from here. You can see 3.57, and it's not showing any short. Is taking 0.028 milliamps, but there is no light at this DC jack. So we know that if I put my multimeter into the voltage range, DC range, and let's see at this fuse, the fuse in this corner here, this big fuse here. So I can check here. Let me just go in the microscope first. So yeah, this fuse is for the DC jack power. So the multimeter is showing 16.4 volt here, which is okay. Yeah, 16.4. So I'm receiving 16.4 at the multimeter with this on this fuse. So it should be available here also. So fuse, after the fuse we have 16.4. so this DC jack is okay. There is no issues with the DC jack, and this is the DC jack. This is fine, but there is no light on it. So the first thing I'm going to check is do I have my PP bus G3 hot available, which is on this coil. So let's go on the microscope again. So this coil is responsible for PP bus G3 hot, and I don't receive my PP bus G3 hot, which is the main power rail. So it's not showing up here. So let me just go into the beep range now, and I will check if there is some shortage on this coil. So it's an open line circuit, there is no shortage. So the next thing I'm going to check is the PP3V42, which is available on this coil here, and is showing short to ground. Okay, let me just take this opportunity to explain what happens here. PP3V42 and PP bus G3 hot, how they form, and what role they play in powering the laptop. So we know that we have a PP3V42 coil short to ground. Next thing, I'm going to the desktop and I will see my okay. So you can see this is the adapter power, PPDC in S5 charger over here. This is from the adapter. The voltage is 16.4. They come here and they go through these iRush limiter two MOSFETs. They are P channel MOSFETs, and if this is Q7085 and Q7080. So these are iRush limiter MOSFETs, and when we say inrush limiter, so they control if there is any current drawn by the board in large quantity. These two MOSFETs, they can sense it, and they can stop the power to go into the board if there is a high current going into the board. So this is like a security for the board. After that, we have here a dual diode here, which is the D7005, and it's available here. You can see here, it's here. So what it does, it gives power to this ISL 6259. ISL 6259 IC generates PP bus G3 hot, which is our main power rail, which is here. You can see that, and there is a fuse here, and there is a coil L7030. This coil is where you can get your main power rail voltage. To generate this power to generate this power at this coil L7030, this MOSFET Q7030 here, this is responsible, and this is these two MOSFETs are responsible to generate this power through this IC. So this IC receives power from, as we spoke earlier, from the adapter, and you can see this power is coming here, and then it goes through this dual diode, and then it's called charger DC in, and this power is going into this ISL 6259 at pin number 2. Now there is another thing that we need to look at, the one we were talking about, PP3B42 being short to ground, which is this power here. This power is also coming to pin number 12. You can see here at pin number 12 this power is coming. PP3B42 G3 hot. So we have the main rail coming from there, and we have a 3.42 volt coming also to this ISL 6259. When this power comes to this IC, then we will receive PP bus G3 hot, so which we are not receiving at the moment, but there is no shortage on this one. However, we have a shortage on this output, which is the PP3B42. PP3B42 is short to ground. That could be one reason that this IC is not performing or is not generating enough power. Now we can find out where this power is being generated and how this is generated. PP3B42, if I click on that now, so I will have PP3B42. Sorry, it's just okay. So what do I have to do to get this? Okay, I've got that one now. So I will do one thing here. I will select PP3B42 here, and I will see where this PP3B42 G3 hot is being generated. Okay, so this is the power flow chart, how the power is flowing. So we are not interested here. This one is with PP3B42 is being generated by U6990. So let's go there directly. So this is U6990. This is generating PP3B42, and I will select, go in the PDF for this. Okay, so PP3V42 is being generated here. You can see here 3.42 G3 hot supply is being generated through this IC, and you should get an output here on L6995, and this is the coil that we have short to ground. So we need to find out exactly what is faulty on this board, but there is something in this area which is causing this coil to go short to ground. Now how this is generated, look, PP bus G3 hot is here. When it receives PP bus G3 hot or DC in connection, so we are using the PP 18 volt DC in connection, so this is the DC in connection. So if the battery is connected, then the power will come from here. If the charger is connected, then the power will come from here. So in our case we are just connecting the charger, so this is the entry point for the voltages, and they will go through these dual diodes, and they will enter this IC, and they will create PP3V42 G3 hot, and that will enter into the ISL6259, and ISL6259 will generate in return PP bus G3 hot. So that's how it works. Now I will just take you back to the PP bus G3 hot where it's being generated. So let's see if I go there. Okay, PP bus G3 hot, and we will see. Yep, and you can see PP bus G3 hot is being generated by ISL6259. So we have a PPDC in charger. This is the power coming from the charger. So I've already explained this to you, no need to repeat, but just a small overview again. So this IC is generating the PP bus G3 hot, but to generate this we need PPDC in. That's one power, and the other power we need is the PP3V42 G3 hot. So we have a short to ground on PP3V G3 hot. Now how to test where the fault is? This is another thing. This is something else. So we will go into the microscope and check how we can find out what part of PP3V42 is because there is IC and which is generating PP3V42, or the ISL6259 where this power is going to. Either one of them is causing the short to ground. So it could be the IC that's generating PP3V42 G3 hot, or the ISL6259 where this power is going to. So if ISL6259 is short to ground, then the PP3V42 G3 hot will show short to ground. However, I mean, it is possible that the IC which is creating PP3V42, that IC is okay. However, when this power is going towards ISL6259 is short, and that shortage is causing a short on the coil also. Just to clear this situation, we will go to the microscope and check. Let me go to the microscope, and this is our microscope. I will take you to the coil, which is the PP3V42, which is here. So this coil is showing short to ground. What we can do is we can just confirm again that it indeed is showing short to ground or not. So the multimeter is in the beep range. and we can see it's short to ground. This is short to ground. Okay, let's see which side of this coil is short to the ground. Okay. So my hot air station is being I just powered it on, so it's warming up. Let's check one more thing. We need to see which side of the coil is what. So let's see. So you can see when I remove, okay, you're not on the desktop, so let me take you to the desktop now. Okay, so we know that this coil is short, right? So when I remove this coil, and if I receive the shortage on pin number 2, then the short area could be where this PP3V42G3 hot is going to. If the pin number 1 shows me short, then quite likely the U6990 is short. So this is what we need to check. So if pin number 1 is short and pin number 2 is not short, then we will go towards this U6990. If pin number 2 is short and not pin number 1, then we will go towards where this PP3V42G3 hot is going, and we know this is going to ISL 6259, which we already seen in the schematics. So this is PP3V42G3 hot. Okay, so let's go back to the microscope. Let's remove it. No, this coil looks bad. Yep. Okay, let's check which pin is it. The coil's pin number 1 or pin number 2? Which one is short? So how do we know what is what? Let me just go into the microscope, the schematics. So the right side is the pin number 1 and left side is pin number 2. So we'll check, is it the right or left? So ground check, and we'll check. So pin number 1 is not short to ground, but pin number 2 is short to ground. So okay, so pin number 2 is short to ground, and we know that pin number 2 is PP3V42G3 hot regulated power, and this power was going into the ISL 6259. Okay, and ISL 6259 is here. This is ISL 6259. Don't know if you can see that. Yeah, you can see that. So this is ISL 6259. At this point I will remove the ISL 6259. Okay, remove the ISL6259. Now I will check if I still have short on the pin number 2 of the coil, and we don't have a short, so it is quite likely that this area, this ISL6259 was damaged or shorted, and that's why this point of pin number 2 was going to the pin number, yeah, it was the pin number 12. So pin number 12, this is where the PP3V42G3 out was going. So it was being created on that IC and it was going in the pin number 12 of ISL6259. So the ISL6259 was short, and that short was visible on pin number 2. So when we remove the ISL6259, so there is no more short here. So this area is clear, this area is clear also. We'll change the ISL6259. I have ISL6259. Let me check where it is. Okay, I have a working ISL6259, which is this one. And after I put this IC, we will check that if there is still any short. So if there is a short, that means this IC is not responsible. The most likely is going to be this one. Okay. Okay, let's check for the shortage. If we have a short on pin number 2, so we don't have short on the pin number 2. Let's thin this area of the coil. Okay, just check the pins. Yeah, they look good. Just clean it. Okay, let me remove the flux first. So the flux is removed, so that looks okay. That's okay. It's fine. I don't know if you can see that. Yep. So they are all shiny and they look good. The connections are okay. That's fine. Okay. Let's put the coil back on. To put some flux first. So the coil is on now. Let's check for the shortage again one more time. So we don't have a short now. Let's give it a clean. Okay, let's check if it powers on now. Okay, give power, and we have a green light. You can see the light and the fan is spin, so it's working now. So that's that was the job. Only the ISL 6259 was faulty. I hope you have learned something on this video. You learned how to diagnose a fault and how to diagnose the shortage. In this case, the PP3V42 generation, the IC that was creating PP3V42 was fine, and after it was creating PP3V42, where this PP3V42 was going to was the ISL 6259, and ISL 6259 being short to ground was causing a short on the coil also. And once we remove the coil, we diagnosed it with the pin, which pin was causing the short. And if it was the pin number 1, then we could go backwards where this being generated. If it's pin number 2, then we can look for where this PP3V42 is going to. So thank you for watching. I hope that you have learned something from this video. Just before we go, I'll just check it on the screen also if I have a display. Okay, let's see. Okay, we have a fan spin and we have a light on the DC jack now. You can see the fan is spinning. We have a display also. Yeah. So is it gonna show me the folder sign? Because the hard drive is not connected. Yep, we have a folder sign. So this job is done. Thank you for watching, and I hope you must have learned something from this video. Do like and subscribe to the channel if this video has been useful to you, and leave any comments if you have any questions that you want to ask. I'll try my best to answer. And that's it. See you in the next video. Thank you. Bye.